Good morning. This is my science talk 5, and I'm basing it on the scientists, and of course, engineers have not been covered. And at the risk of repeating myself, I'm a chemical engineer with a MN and a MSc, with an MN and MSc. This time carried a special edition, Great Scientists, and I'm looking at the scientists under chemistry, and not as such going through what science covered. It is for you to discover. I'm going to add a little bit of extra to it. All right. So I have jotted down some notes, and there are 5 scientists whom I'm going to cover. 4 of them from the issue. I thought I would do Pauling, Linus Pauling, but then I saved him for another time. And the 5th is Professor Peter Zandstra, the head of, he's a Canada researcher in the Institute of Biochemical and Biomedical Engineering, IBBME. He's affiliated, of course. He's a part of the Department of Chemical Engineering and Applied Chemistry, but I don't know if he's he was the head of IBBME, but I'm not quite sure. His research deals with stem cells. I'll come to it in a minute, or I'll begin with it. All right, I'll begin with it. Current scientists get precedence over past wonderful scientists. All right. So he deals with stem cells, and a part of his research deals with trying to get the stem cells to become cardiac tissue or pancreatic tissue. So now I gave this some thought, and with in this research on the internet, and stem cells are, of course, can be obtained from fetal tissue, aborted fetal tissue, embryos, of course, they all become children, but you could make in vitro fertilization procedure, and then you could get embryos, and from which you could use stem cells. Stem cells have the ability to convert to any other cells given the right conditions. So I suppose a fetus begins with the fertilized egg, which has stem cells. I suppose, I don't know for sure. And stem cells are also there in connective tissue. This is from past research from my son's biology book. My son has switched to social sciences. He's going to his 3rd year, but when he was in high school at Abelard, he used to have a biology textbook which said that connective tissue has stem cells. All right, now to what is the characteristic of a cardiomyocyte, a cardiac muscle cell, comes into question if you need to convert stem cells into cardiomyocytes. Now, they have myofibrils, which have long chains of sarcomeres, the fundamental contractile units of muscle cells. So it aids in expansion and contraction of the muscle, sarcomeres. And another characteristic about it is that it has very high mitochondrial density, which means that it can make ATP quickly. The heart muscle, cardiomyocyte, heart muscle cell, cardiac muscle cell. So how would you affect this? You could get in regular cells, but that's not going to convert stem cells. Regular cells, and hope for mitochondria to become denser, which means mitochondria has chromosomes, if I remember correctly. Chromosomes have DNA. So more of DNA would make mitochondria denser. More of traits, more of characteristic, if you think about it, the heart is a complex organ. It pumps blood, it collects blood, and then it beats. So that's all being discussed on the Wikipedia page. Beating is the pacemaker. You could have an Iron Man's heart, Iron Man the movie, but that would be a chemical contraption, biomedical contraption. Um, and So, how would you do high mitochondrial density? Long chains of sarcomeres, you could, if you analyze the structure, hope to make it. All right? High mitochondrial density would eventually result. The chromosomes are fixed. You can't have more than 23 pairs of chromosomes. If it makes ATP quickly, there could be the possibility that there's another reaction happening. Now, I've forgotten in the metabolism procedure, cells produce ATP, is that correct? To look at my biochemistry textbooks. So I suppose making ATP quickly is not necessarily due to high mitochondrial density. It's due to faster metabolism, a quicker, could be connected, the pacemaker and the cardiomyocyte. I said it right. Cardiomyocyte. Uh, that might be it. That might be it. So it could be quicker heartbeat. So there could be more interwoven functions. But then you cannot make a cardiomyocyte if you focus on the pacemaker. It's independent of the pacemaker. The cardiac muscle, the heart, consists of several cardiomyocytes, of course, this is all basic. And high mitochondria, because number of chromosomes are fixed. You could have more DNA, which means that traits are concentrated in the heart and not in the brain as we thought. As I thought, not we thought, as I thought. But then the brain and the heart are interlinked, of course. Signals travel fast. So, well, it's for Professor Zenstra to figure it out. He could look at making sarcomeres and cells, regular cells. So you could add saliva to stem cells. Saliva has DNA and cells. This is from a Wikipedia research. And hope that the stem cells start to mimic the cells are epithelial cells, skin tissue. And then there's more derm layer, the epiderm, the mesoderm, the ectoderm. Um, so Rome was not built in a day, of course. You'll have to ponder about this and think about it. It's best if you were to work in the lab and then you could actually get down to doing things. You could look at the heart of chicken. I know it's sad. I'm a vegetarian, so I feel even worse, even sadder for chicken, the heart of a chicken, and then analyze it. And then, but then of course, human beings are different. So, how would stem cells become cardiomyocytes? It's a good fact. You could add saliva, but you would have epithelial tissue, but then you would have DNA, it would become epithelial tissue. To make it, it's, but then epicytes, right? Epitheliocytes would become cardiomyocytes with myofibrils and mitochondria of high density. Well, I suppose all his excellent students can think about it, or he can, of course. It's not been much help to me. I even included Professor Shoike, Professor Coachshot, and the others. I thanked them in an essay. And my committee members, my defense committee members, all of them. But currently, I have an ongoing procedure with the graduate coordinator of the Department of Chemical Engineering and Applied Chemistry, University of Toronto. I'm pursuing a PhD. I have 5 extra courses, see? And all my papers have been published on LinkedIn. You can look at them. Few on Facebook, but not made much headway. And um, um, I've submitted all those papers and a couple more ideas. I did a scientific experiment the other day at home, chemistry experiment. I made collagen because I have ordered a bioret reagent, and it came to me finally after like 8-9 months. It came to me, or 7-8 months. I forget the exact count of months. And I did that, and that was also what I submitted. Please look at my LinkedIn page now. Moving on to 4 other scientists. Humphrey Davy. We will go back to, and I will perhaps say, isn't this inspiring? Galileo, Einstein, Marie Curie. Is this Maxwell? Newton. Newton. Newton was one of the most iconic because he changed physics the way, oh, there's mathematics. I'll do mathematics next. Humphrey Davy, brilliant chemist. There's this, he found out, he discovered new nitrous oxide, the use for nitrous oxide, laughing gas, and apparently he shared it with poets Samuel Taylor, Coleridge, and Robert Southey. I don't know Robert Southey. Should read a couple of his poems. And Thesaurian Peter Mark Roget. You have Roget's Thesaurus. Roget's Thesaurus. Roget's Thesaurus. And Southey enthused that the atmosphere of the highest of all possible heavens must be composed of nitrous oxide because it, it makes laughing gas, right? Yes. Dentists used to use it a long time back, not anymore. There's an episode in Mom where the with a boyfriend of hers, he's a dentist. The one of the heroines, the older heroine, the main heroine's mother, she plays the role of the mother. They both take nitrous oxide and laughingly discuss the travails of your marriages and the travails of your life completely. Why did she leave you again? That's what nitrous oxide does. Anyways, nitrous oxide. Now, U238 is present in pitchblende. And he also discovered radioactive elements. Who? Humphrey Davy, right? Who I have to say? Humphrey Davy. And no, he did not discover a radioactive element. I've forgotten the thread of my thought here. Why did I write this down as notes? If you would bear with me for a minute, please. He separated compounds by passing an electric current through it, and then so he did sodium chloride and potassium chloride and discovered sodium and potassium, isolated sodium and potassium. Now, how would he have done this for radioactive elements? I think that was my question. From pitchblende, if he wanted to take out U238, U238 has a very long half-life, and that's the consoling part. And then it gives out an alpha particle and becomes thorium 234. Of course, U-238 losing an alpha particle, thorium-234. And how would you separate out U-238 from pitchblende? Is the question. So I suppose you'd use pitchblende, but you would have unwanted materials in pitchblende. Marie Curie did use pitchblende completely, but then if you wanted U-238 for an experiment, how would one isolate U-238? Thinking along the lines of Humphrey Davy. Uh, well, you could extract, but then it would not be and I don't think inside pitchblende it is radioactive as a part of pitchblende. Otherwise, over the centuries, it would have disintegrated into a completely lower non-radioactive chemical. Its radioactivity but then it has a very long half-life. It's do you know what a half-life is? Of course, atomic weight comes down to half the so U-238 becomes is this my math this poor? 117, 180, 190, 190. U-238 becomes 119. And then it is and we'll come to Mendeleev in a minute, but Mendeleev didn't categorize radioactive elements in his periodic table. That's he has only U-238 on the periodic table. U-235 is not there on the periodic table. That was my thought on Dmitry Mendeleev, but hopefully I'll get some other thought once I look at the inspiring essays in Time magazine. This whole idea came to me after I picked up another Time magazine yesterday, The Science of Creativity. It was a good issue. There was a lot of information there, but I thought they could have. But I learned about some poets whom I didn't know and authors whom I didn't know. So they're all famous literary experts. So that it all and some scientists also. Okay. So I urge you to look at it, the workings of the brain, and 7 tips they had for you to become more creative. But I didn't sleep well, and I didn't sleep well tonight. See, I woke up early, so that didn't go. All these days I've been sleeping quite well. Anyways, so how would you separate U-238 from pitchblende? All you had to do was pass um, it's in the form of uranium oxide, I think. U-205. Huh. U-205. So you could use some of the reactions for oxides and then hope it reacts. Only that portion reacts. And then oxides all have characteristic reactions. Offhand, I can't think of any, but I'm sure you can with reference if you can't offhand think of any. And then U-205 would come out, then you get it back. You reverse the reaction, and then you would have U-205 right in front of you. Uranium is a very stable element, but then it exists as U-205 in pitchblende. So that's a Humphrey Davy. I pulled a Humphrey Davy on you now. Next, August Kekule. August Kekule, of course, we all know snakes frighten me unbelievably so, because I have a phobia about snakes. My son keeps teasing me, but the sight of a picture, etc., bothers me. I cannot look. I'm a devoted Hindu or an ardent Hindu, but then all the gods scare me because they all have snakes associated with them, except for Brahma. But then a woman does not want a man with 3 heads, does she? But then he's a creator, he's the god of creation. So hopefully he'll help me from afar to grasp the science of creativity and end up being more creative. Anyways, So August Kekulé, of course, came up with the structure for benzene, the ring-like structure. He dreamt of a snake holding its tail in the night and came up with the closed-membered ring. Now, this morning, he also said that carbon could combine with oxygen and nitrogen and, of course, hydrogen, benzene with C6H6. So I looked up on C6O6 and C6N6 on the web, and C6H6O6 is there. C6H12O6 is, of course, glucose. There's acetic oxalic anhydride, it's called, or dehydroascorbic acid. It is not quite close membered. There's a branch which kind of is hanging there, and etc. It's a five-membered ring. The other C is in a branch, or that's the way they made it. C6N6 is triazobenzone, and PubChem, and this is a very nice one. It's like benzene, but the nitrogen molecules, two of each are on either side. Of course, the ones at the corners, top and bottom corners, don't join together. But these two, or all the three, they here, and here, are joined by double bonds, nitrogen molecules. Then I listened to watched a very short video. It stopped after becoming a member. It just stopped rudely halfway through study.com. I urge you to look at it. It's a very interesting website for students and teachers. I'm neither. I don't fall into either category, but I could say I'm a researcher, and I do extensively. I've published, etc. So I have other hard copies of papers too, back from my time work days and graduate days, which reminds me that I have a backlog of two papers, and one more submitted. What happened to those? But I don't have them with me to publish on my own. Third, I have. Third, I have. I might publish it. It means typing, so it's going to take some time. Anyways, it occurred to me that now, after all these years of having been a chemical engineer, that carbon in aliphatic compounds, of course, follows its tetravalency and 4 to 4, but in benzene, only 3. Where's the other one? So apparently, it's a floating electron. There are 3 double bonds, and in a benzene molecule, or a closed ring, which is depicted as a closed ring with 3 double bonds, which still does not explain the other 3. They're all floating electrons. They're not taken into account. Now, if you were to make benzene, you would have to take 6C plus 3H2. Under the right conditions, it will become benzene. I'm a believer, see, I'm a believer. I've done these things, proven that they can be done. So I urge you to get fired up with enthusiasm and see if you can do so to one of these in the labs or elsewhere. Third, we come to Dmitry Mendeleev. And as I said, the thought that I got was, how were radioactive elements classified? Let me see if one was my small town in Siberia. Oh, 14 surviving children. It was one of 14 surviving children. It's in Russian, but the letters are the same. Right, some lettering is the name of the periodic table. Yeah, radioactive elements are not included. Or are they? Did he originally include them? They got like U238. No. It's based on atomic weights. That's the interesting part. Periodic table is based on atomic weights, which means isotopes should have been listed, Mr. Mendeleev. If it had been based on atomic numbers, then you would have had to have had U235, U238 there. You've left out a few, but then they all disintegrate and turn into other elements, etc. So it's all right. But what else did we know? Did we know any interesting anecdote about Mendeleev? Uh, time gave. Time did give me some material. He worked hard to push agricultural and industrial development in Russia. When was he there? He was there from 1834 to 1907, before communism, and of course before the Free Revolution. Uh-huh. And then that is all about Dmitry Mendeleev. Next we come to Robert Boyle. Uh, and he said, of course, you all know Boyle's law. Pressure of a gas is inversely proportional to its volume, or uh, the product of the pressure and the volume is a constant at all times. Given constant mass, which kind of pressure is, of course, force per unit area? Pascal is newtons per meter square, and 1 atmosphere of pressure is 760 millimeter Hg. And force, I tried to look up Navier-Stokes and equations to try to correlate this to fluid mechanics, this law, and I could. PV equals nRT, of course, a constant, but the temperature changes. So if you were to keep if you were to change temperature, PV would change. Universal gas law constant, PV equals nRT. The thought that came to me was partial pressures, of course. How would you calculate the partial pressure of oxygen in the air? It's 21% of the atmosphere. So 1 atmosphere or 760 millimeter of Hg mercury into 0.21%. And there's a little more formula, but this will do for a rough calculation. It's like Fahrenheit to degree centigrade. There's actually another formula to be precise, but so high pressure, you say, right? In a can, when you have a spray can, the liquid is stored under high pressure, which means that the volume is small, of course, inversely proportional, so the pressure is high. And 1 atmosphere of atmosphere, constant mass, which means that in this room and that room, which is not the same, it's not the same, maybe the kitchen and that room, with that, then the pressure PV would be constant in both rooms. Air would be constant. There would be the same mass of air, and if the volume of air is different in both, then the pressure in both rooms would be different. Anything else? I'm thinking by Navier-Stokes equations, force per unit area, fluid mechanics, velocity will have to come in. Pressure would change because pressure is force per unit area. Force is, of course, according to Newton's law, mass into acceleration. But then this is fluid mechanics, but that's the definition of force. If force changes, then perhaps you can have an enjoyable exercise. Try thinking this out. Um, Velocity is crucial to pressure. Velocity changes, then um, acceleration changes. There is acceleration. If velocity changes, there is acceleration. So pressure changes. Pressure goes up, comes down. Area is going to be constant. See? So you say pressure increases, force is increasing. When it's windy, the pressure of water is increasing. Well, enjoy yourselves. Thank you. And by the Time magazines and of course Scientific American, there's an issue of Scientific American also, I think, which deals with scientists. Maybe I'll do Scientific American the next time. And thank you for listening to me. I didn't even use my whiteboard and pen. I wanted to jot down, but I just looked at the notes and spoke. I should jot it down. You all know the benzene ring. You all know the benzene ring.